So when you interact with a website, there are actually a lot of layers that your request is going to go through. And I think talking about these and making sure you understand how it all kind of works can just make you a better web developer. So I'm going to walk you through the different layers that I have seen when building out web applications when it comes to caching and just compute. And I think hopefully this will be a useful talk for you all. Okay, so step one is that you as a user, you make a request to a website. Where exactly is that request going? Obviously, it needs to hit a server somewhere, and that server is running some compute and probably fetching a database, whatnot. But as your system becomes more complex, there's typically different layers that sit in between your browser's request and the actual data that's living on disk somewhere. Okay, so the first step, typically, there is a CDN. Okay, so a CDN, a content delivery network, is taking your request and it kind of sits in front of your request in your actual server. And so one CDN you probably have heard of is called Cloudflare. AWS has one called CloudFront. Basically, it's a bunch of nodes that live across the entire globe. And based on your user's geolocation, it's going to route to the closest node so that the latency is low for making the actual request and getting the data back, okay? Now, the second part of the CDN is typically it has caching built in. The second important thing about the CDN is that it has caching built in. So the CDN will eventually reach back to an API, get some data, and it's going to store that so that later on, if any other users that are in that geolocation, they will also get back that information and it's going to load really fast for them, okay? I also want to point out that typically on a CDN, at least on Cloudflare and AWS, you can actually have something called edge functions. Now, an edge function is compute that you run in the location of the CDN. Instead of it having to go all the way to your server to run the compute, you could have these smaller functions that you might have seen like Next.js has middleware functions that runs the stuff a little bit faster so that the time of travel between this compute into CDN and your browser is much faster. Additionally, for this CDN layer, typically there's something called like KV storage where you often want to be able to store stuff that you've computed inside of the node that's closest to the user. So again, to kind of highlight the purpose of this KV, it's a distributed caching system. It's a distributed storage location. So for example, if you have a user that's living in a completely different location, they would be hitting a different CDN node. That node is not going to be reaching back all the way to the KV cache. It's actually going to be loading from a KV instance that's close to it. And behind the scenes, these layers will kind of replicate their caching between them. Okay, so again, the data will reload fast for all users, and it has a way to kind of share all this caching. Now, at some point, if you're trying to request something from your server, the CDN has to stale the cache at some point, right? It can't just store this stuff forever. Sometimes data goes stale. You need to go back and fetch the real data, the live data from the API, which leads us to the actual next layer, which is like the computation layer. This is where your servers will live, and typically you'd have like one main server living maybe in like one region. Sometimes you can have, east and west type of setup. But the goal is to try to reduce the number of requests to your actual server so that you can serve more traffic and not have as long as latency. Because obviously to go from the browser to the CDN to your actual server, which may be a little bit further away from where the CDN node is, it's going to incur costs. Like this costs time for the request to go all the way there to get the data back. Okay, so this would be your Go server. This could be your Node.js, your Hono server, your Python server, whatever, which can serve back the templates and serve back the data so that the CDN can cache it so that other users who make the request who are in that area can kind of get a really fast response back, okay? Now, obviously for web applications to work, the server has to go and store and retrieve data from a database. But I will say that there is typically a layer that's in between the server and the database, and that is another caching layer. And this could be Redis. You could have like a Redis cluster, which is allowing your data to be stored in memory. So when your server needs to fetch, for example, the latest top 100 movies on Netflix, it doesn't have to go to the database because eventually the database is going to hit disk and it's going to be kind of slow. So instead, having some type of Redis cache between your server and the database can make the request return data much faster. And typically you have a cluster of these. You could have different shards that kind of distribute the data to make it run a lot faster. You can also have replicas depending on your uptime requirements. But that is another layer that kind of sits in between the server and then the final layer, which would be like your data storage, your database. And this is where you'd have Postgres. You could have some other type of thing like MongoDB. You could have DynamoDB. And of course, the database is where all the data for your application is stored. And eventually that has to hit disk. This is the slowest part of accessing the data. And typically Postgres has memory that it uses the cache stuff as well. But the idea is that you're trying to reduce the amount of requests that need to actually happen to disk, because usually this is the slowest part of data, right? Fetching data from disk, even with, solid state drives and other things, it can still take time. And so we have all these layers kind of in place so that when a user makes a request to your web application, they can get back that static HTML as fast as possible, assuming it doesn't change much, right? If the page or the data doesn't change much, or you can afford having potentially stale data show to a user, then that's why you want to have all these caching layers in place. But often, a lot of times you just want to actually have live data, or you need to do a post request to insert some data, which of course would just bypass the cache and go straight to your database from your server. Because if you're doing an insert into the database, you don't need to hit Redis. You just go straight from the server to the database. So anyway, that's kind of an overall idea of how the layers kind of work when it comes to caching. The moment from your browser makes the request all the way to your CDN, to your server, to your Redis cache cluster, into your database. There's probably stuff that I missed out on this, but I wanted to give like a quick little overview to maybe people don't really understand what's happening when you make a request. And that's kind of what's happening. So if you guys enjoyed this talk, let me know. Also, this is a new tool I've been building out called SketchLab. It's free to play around with. It's at sketchlab.webdevcoding.com if you want to also play around with this. Let me know if the layers actually helps when it comes to teaching, or if this was actually more confusing, because obviously the traditional way of teaching is using like sequence diagrams or flow charts, but I wanted to bring in like a 3D perspective because I do think it makes it a little bit more enjoyable and fun. But you guys let me know. Anyway, hope you guys enjoyed. Have a good day and happy coding.